All right, next I want to really focus in on the radical functions. All of these are going to be powers between 0 and 1, and radicals basically mean roots. So cube roots, fourth roots, fifth roots. There are powers between 0 and 1 that are a little trickier to classify just as a root, but I want to look at this specific set. So these are, like I said, these are our baby radical functions. We're going to do things with these later on. I don't know if I said it in the last video, but the power functions are our baby polynomials, which we will really get into in Math 142. And then we also still have the baby rational functions that we'll do next. Okay, so just like before, we can notice some interesting things when we're looking at the roots. So we have a fifth root, we have a fourth root, we have a cube root, and we have a square root. Notice the square root, as x gets big, gives us the biggest y values, then the cubed, then the fourth, then the fifth root. So the higher the root, the bigger the denominator, the flatter this graph gets as x gets bigger. Between 0 and 1, we again have a flip-flop here, right? So when we look between 0 and 1, the fifth root actually gives us the tallest graph, the biggest y values. The fourth root's next, then cubed, then square root. But if we're looking in quadrant 1, notice they do all have a really similar shape in quadrant 1. It just gets a little bit exaggerated as that denominator gets bigger. And of course, it'll look different if you have something like 2/3 or 3/5, similar shapes somewhat, but there are some interesting things. Notice also it doesn't have to be written as a fraction. You could have a 0.3 or a 0.4 or a 0.9175 or whatever, and they're all going to give you something kind of like this in quadrant 1. Okay, so let's look at quadrant 2, 3, 4, look at the rest, and you can see that some of them have something going on and others don't. So let me turn off the odds first. Okay, so the even roots, you don't have anything at all happening to the left of the y-axis, and that's because you can't take square roots or fourth roots or sixth roots of negative numbers. That doesn't work, right? So these have interesting domain restrictions, the even roots do. Square root and cube root are the ones that are going to go on your parent function graph. So go ahead and draw those in and try and summarize. Here are your odd roots. They do have something going on. In fact, they have some symmetry. They're odd functions. And if you looked at a seventh root or a ninth root, it would be similar. And notice they look very much like we took an x cubed or an x to the fifth and turned it on its side. And it's not just that they look like that. That's exactly what they are. And we'll talk about that when we get to inverses. So there is something interesting going on there. And then those are kind of the typical ones. I do want to show you that there's like other weird possibilities, just so you know, but don't feel like you have to memorize when this will or won't happen. But if you get these fractions with an even power on top, you can actually get the even shape. The even root didn't do it because of the domain restriction, but here it's a cube root, so we can plug in negative numbers, but the squared gives us the symmetry. So kind of a cool weird one, just so that you know there's other things out there. The 3/5 power gives us something kind of similar to the cube root or the fifth root, but it's a little bit straightened out, kind of strange looking. So those are different radical shapes. So again, the cube root and the square root are the ones that you really want to have the details on, but then also this general understanding that higher odd roots will look similar to cube root and higher even roots will look similar to square root.